So this next style of problem determines whether a precipitate will form when you're combining two solutions. Now, in order to do this, we're going to have to calculate, do a trial K expression. So let's look at this example where we have 200 milliliters of 0.0040 molarity beryllium nitrate added to 200 milliliters of 0.00020 molarity potassium hydroxide. And you're asked, will a precipitate form? Now, just as we have in the previous problems, we're going to start with the dissolution equation. Now, something to note for both of these is that the beryllium is with a nitrate, which we know to be completely soluble, and the hydroxide is with potassium, which we know to be completely soluble. So both of these two solutions are going to have molarities of the ions equivalent to the molarity provided. Alright, so let's write it for those two. So we have beryllium nitrate, BeNO32, which is completely soluble. So I'm only going to do a one-sided arrow, turning into B2 plus aqueous plus 2 nitrate ions. And we're just going to basically ignore those. And then we have the potassium hydroxide dissolving completely into potassium ions and the hydroxide ions. And once again, we're just going to ignore the potassium because it's a spectator ion. Okay, so that's going to be a spectator, that's going to be a spectator, and we're basically ignoring them. So we know that since this is a question asking about whether precipitate will form, we know that the precipitate is going to be composed of the beryllium and the hydroxide. So I'm going to write a third dissolution equation for that. So we have BeOH2 solid, and this one's going to have a two-headed arrow. Goes to beryllium ions, aqueous, and hydroxide ions, aqueous. Alright, so this is the one we really care about because this is the dissolution equation. Now, I'm going to write my Ksp for this one because this is the one we're going to be plugging our values into. So our Ksp is going to be Be2 plus times OH minus squared. So knowing this, we're going to start out by looking at our two solutions and finding the molarity of the ions beryllium and hydroxide. And one thing you want to keep in mind is that if you're adding two solutions together, we're going to be doubling the volume, but that's not going to change the number of moles of the beryllium that we have or the moles of the hydroxide we have. But we will change the molarity of the solution because you've now doubled the volume. So in order to account for that, we can multiply our molarity by the dilution factor. Okay. And our dilution factor in this case is going to be the 200 milliliters over the total 400. So let's look at the beryllium one first. So for the beryllium, we have a molarity of 0.0040 molarity for the beryllium nitrate, and we're going to multiply that by the dilution factor. That is the amount we're adding over the total volume altogether. And that's going to give us our new molarity for the beryllium ion of 0.0020 for the beryllium. We're going to do the same thing for the hydroxide. So the hydroxide was 0.00020 molarity. Same dilution factor because it was 200 milliliters being added to 400 milliliters. And that's going to give us a concentration of 0.00010 molarity for the hydroxide ion. Alright, so now we know the concentrations of the two substances. We're going to plug these values back into our expression for Ksp. Now, since we don't know if it will completely dissolve, we're not going to call it a Ksp, we're going to call it a trial K. Alright, so I've copied my two molarities over, and we're going to do a trial K. And the trial K is going to include these molarities, and we're going to plug them right into the expression that we have. So that is the concentration of beryllium, so 0.0020 times the concentration of the hydroxide ion. And if you remember in our formula, the second term was squared. So my trial K is going to come out to 2 times 10 to the negative 11. Actually, that should be 2.0 times 10 to the negative 11. So now what we're going to do is compare our trial K to the Ksp that we were provided in the question. So we weren't actually given one in the question, so I just went and looked it up, and our Ksp in the text is 1.6 times 10 to the negative 22. Okay, and our trial K was 2.0 times 10 to the negative 11, which is larger than our Ksp. So we're putting in more than is able to dissolve in this question. So since the trial K is greater than the Ksp, we know that therefore a precipitate will form. So our answer is yes. But it's not enough to just write yes or no to one of these questions. You do need to show your work.